Okay, so on this next example, what we've got is 3 points, and we want to know if those 3 points lie on the same line, or do those 3 points lie on a parabola? Okay, a degree 2 quadratic equation. So first of all, I'm going to start this problem by labeling these points. 2, 9 is going to be my point A. That's too thick. -1, -6 is going to be point B. And my third point, point C, is going to be -4, -3. So to show that points are not on the same line, they're not going to be on the same line if they do not have the same slope. If the points are going to be on the same line, you will get the same slope numbers. So they want us to find the slope between point A and point B. So they want us to find the slope containing points A and B. And then they want us to find the slope containing points A and C. Now, if these come out to be different numbers, these points are not collinear or non-collinear. So the slope of the line that contains points A and B, we're going to do change in y, so -6 minus 9 over change in x, -1 minus 2. Okay, so the slope of the line that would contain points A and B is -15 over -3, which is a slope of 5. Okay? The slope of the line that contains points A and C, we're going to go change in y, which is -3 minus 9, over change in x, -4 minus 2. Okay? So that's going to give us -12 over -6. -12 divided by -6 gives us a slope of 2. Those are not equal slopes, so A, B, and C are non-collinear. That just is a fancy word that says not on the same line. Okay? So if they're not on the same line, let's say, for example, now I don't think they look like that. If they're not on the same line, then there's some kind of parabola that would contain those 3 points. That's basically the idea behind this. Okay? I've got to still be able to see those points. Now, parabolas have the equation in general, y equals ax squared plus bx plus c. And so what we're going to be able to do from these 3 points is form 3 equations that would satisfy that general form for a parabola. Okay? So for the point 2, 9. Okay? Remember, this is an xy ordered pair that they give us, so that's what we're going to plug into this equation here. We're going to have the equation y, which is 9, equals the a value times the x squared. The x is 2. We're going to square that. Add that to b times the x value of still 2 plus c. Okay? So we plug that in for each of these 3 points, and then we're going to clean it up. I think we should go ahead and clean this up and write it in a nice little form. It will be a times 4, or 4a plus 2b plus c equals 9. That's a good form for that first equation. Okay? For the next point of -1, -6, okay, for it to be on a parabola or a quadratic equation, the -6 is the y. We don't know what a, b, and c are here. That's what we're ultimately going to be trying to find. But we're going to have an x value of -1 to be squared plus our b value times -1 plus c. Cleaning that up into something nice and pretty, that'll give us 1a minus b plus c equals the -6. Okay, for the last point of -4, -3, Okay? Y is -3, while x is -4. So plug that in to this general form for a quadratic. And then we'll simplify it. This will give us 16a minus 4b plus c equals -3. Okay? Now what we've got going on is a system of equations. 3 unknowns and 3 equations. We should be able to solve this. Recall what we need to do is pick on one of the values and make it fall out. I kind of think I want to go with the C. Okay? I'm going to take the first with the second equation and make the C eliminate. I'm going to eliminate the C. Okay? And then I'm also going to do, I think I'll go the second with the third and again eliminate the C. Now, the reason I'm choosing to eliminate the C is because those all have a coefficient of 1. And what I think I'm going to do here, y'all, is I'm going to take this middle equation, since I'm using it with both of them, I'm going to take this middle equation and make it have a negative C. And I'm going to accomplish that by multiplying everything in that middle equation through by -1. Okay? So, my top equation here, I'm working on this part first. My top equation is just 4a plus 2b plus c equals 9. Now, when I multiply -1 through everything in that middle equation, I will have -a plus b minus c, that's the whole reason I did that, equals +6 now. Okay? Now, when we go to add those two equations together, we're left with a 3a plus 3b equals 15. Okay? Now, we might go ahead and divide everything through by 3 and just have a plus b equals 5. That might be a better form to use. Now, the next thing we're going to do is we're going to add those two equations together. Now, when I take the -1 through this second equation, like I did before, I'm still going to have the -a plus b minus c equals 6. And then I'm just going to recopy this last equation, the 16a minus 4b plus c equals -3. I didn't do anything to it. Now, when we add these together, we've got 15a minus 3b equals 3. And again, I might want to go ahead and divide everything through by 3. I can totally do that. If I divide everything through by 3, I would have 5a minus b equals 1. You like that? I like it. Because now what we're going to do is we're going to take these two equations. We're going to take this equation and we're going to take this equation and we're going to form a system of equations. Two unknowns with two equations. Our first one is a plus b equals 5. Our second equation is 5a minus b, oh good, equals 1. The reason I said oh good is because I already have opposite coefficients for my b. When I add these together, I will have 6a, that falls out, equals 6. And so, y'all, a is 1. A is 1. Keep that in mind. Okay? If a is 1, we should be able to find what b is. 1 plus b equals 5. Subtract 1 from both sides, so b will be equal to 4. Hooray! Okay? So if we know that a is 1 and b is 4, we've got to go back somewhere up here and plug those in to find c. Maybe I'll do that right here in this very last equation. I might even have room to do that up here. So I'm going to have 16 times the a value of 1 minus 4 times the b value of 4 plus c equals negative 3. So y'all, what I got is 16 minus 16. That happens to fall out, leaving me with c is equal to negative 3. Now, what in the world are we going to do with all of that? Well, we're going to go back up and we're going to put the a and the b and the c in to write the equation of the parabola that would contain those 3 points. Okay? Now, remember the equation is of the form y is equal to ax squared plus bx plus c. So y'all, we found that RA is 1, our B is 4, and our C is a negative 3. I wish I would have used some other color than orange here. And so our final answer is y is equal to 1x squared plus 4x plus a negative 3 or just minus 3. That's kind of cool, isn't it? So if you need a degree 2 equation, if you have 3 points, you can do that. Just as, okay, think about this. If you have 4 points, you can write a degree 3 equation, and so forth. All right, what else we got? Oh, good, just a couple fill in the blanks. Hooray. The graph of a linear equation in 2 variables is a line in two-dimensional coordinate system in the plane. The graph of a linear equation in 3 variables is a blank in a 3-dimensional coordinate system in space. That forms a plane in space. Number 2, a solution to a system of linear equations in 3 variables is an ordered triple that satisfies each equation in the system. Graphically, this is a point of blank of 3 planes. What should go in here is it should be a point of intersection of the 3 planes. That's what they were wanting there. All righty, get busy on 9.2. Good luck.